In this question, a charge capital Q dislocated at R vector. It's in equilibrium under the influence of three other charges Q1, Q2, Q3. These three charges are located respectively at R1 for Q1, R2 for Q2, and R3 for Q3. Obtain an expression for the direction of force on Q due to Q3. So we need a coordinate system, y-axis, x-axis. This is the charge Q located at P with respect to the origin. Another charge Q1. These two are located at respectively Q is at R, Q1 is at R1. So the line connecting Q1 to Q will be the direction along which the force on Q due to Q1 act. Since both are positive, Q1 will repel Q from Q1 to P direction. So this direction, Q1 to P, the vector connecting Q1 and Q. The distance between Q1 and Q is R1. We're just writing R1P as Q1 to P, starting from 1 to P. Using triangle law of vector addition, sum of these two sides, R1 plus R1P, will be equal to the third side in the opposite order, R. So R1 plus R1P equal to R. So R1P, which is the distance between Q1 and Q, we can find by taking R1 to the other side. So R1P equal to R vector minus R1. Similar to that, if you have another charge Q2 comes here at a distance R2, the distance for the direction even between Q2 and P, R2P can be written as R minus R2. And for a third charge Q3, R3P can be written as R minus R3. R2P is R minus R2. R3P is R minus R3. The last two is exactly similar to the first one. Now, according to Coulomb's law, the force between two charges KQQ by R square with R cap indicating the direction. If you multiply up and down with one R, it will be RQ, it will be R into R cap. Now, R into R cap is vector R. Vector has both magnitude and direction. This R represent the magnitude, this R cap represent the direction. So R cap will be equal to full vector R. So vector R is R with R cap. As we learned last year, R vector is R with R cap. Now the net force on the charge at P will be FP due to charge 1, FP due to charge 2, FP due to charge 3, FP1 plus FP2 plus FP3. So we can find FP1, FP2, FP3. FP force on P due to 1 will be K Q1 into Q by R1P magnitude the whole Q with direction along R1. So K Q1 into Q by, as per this change we have done, the distance which is R1P magnitude the whole Q into the direction is vector R1. So KQ1 R1P cube magnitude with vector R1P. Similar to this, force on P due to 2 will be KQQ2 by R2P cube direction R2 to P. Same way FP3 will be KQQ3 by R3P cube direction vector R3P. They given the capital Q is in equilibrium. Equilibrium means net force has to be 0. So FP has to be 0. So 0 equal to FP1 is this value, FP2, FP3 this value. All the three common we have K into capital Q. So K into capital Q comes out. So net force is 0. K into capital Q comes out. Q1 by R1P whole cube R1P. Q2 by R2P whole cube R2P. Take KQ left hand side. So that get cancelled, 0 by that number will be 0 only. Q1 by whatever left. Now our aim is to find force on Q due to Q3 direction. So this part will take it separate to the left. Minus with the same term here. Now we only want the direction, so take these two magnitude part to the right along with the minus. So R3P vector is the same whatever in bracket into R3P whole cube by Q3. We can write a vector as magnitude into direction. So R3P vector can be written as R3P into R3P cap. R3P into R3P cap. One R3P and one R3P get cancelled from here. So R3P cap unit vector R3P equal to R3P square by Q3 with a negative sign with the terms in the bracket. Now all this to be expressed in terms of R1, R2, R3 and R. Because the final answer should be only in terms of the factors given in the question. You can't have R1P vector because that R2P vector, all this is taken for our convenience. So all those should be expressed in terms R minus R2, R minus R1, R minus R3. So we are trying to change all this into R, R1, R, R2, R, R3 terms. So R3P will be R minus R3 magnitude the whole square. R1P will be R minus R1 the magnitude whole cube. Vector R1P will be R minus R1. Same way R2P magnitude cube and R2P all changed. So this is the direction for force on Q due to Q3. It's an extra plus here. We want to see the location of Q2 and Q3. Q2 may be here. Q3 can be here. Q2. Q3. These are the directions of force on Q due to Q2 and force on Q due to Q3. Which are respectively represented as R3P vector and R2P vector. This is Q2 located at R2. This is Q3 located at R3.